Module 2 will discuss design information coordination. We will discuss the first steps you should take when you start a rigid pavement design. The first step is to review the project scope of services. You need to know what is being done in the project before you can go collect data for it. The best place to get a copy of your project scope of services is from the department project manager. Contacting your PM will also allow you the opportunity to talk to them about any specific elements related to your project that they may already be aware of. They could probably also provide you with the contact information for other offices that you will need to coordinate with. Once you have your scope of services, you'll want to find out a few key things such as project type. If this is a concrete rehabilitation project, reconstruction, or new construction. If it is a new construction or reconstruction project, you will need to find out if there is a pavement type selection analysis report that would identify if a pavement type has been selected for this project, if it is flexible or rigid or both. If you're doing a project rehabilitation, obtain as-built plans that will provide information on the existing pavement and slab depth. Now that you're familiar with the scope of your project, it's time to start gathering as much existing data as you can. A good place to start is with your district maintenance office. They can give you a great deal of insight into your project. Since they maintain these facilities over the years, they're very familiar with any problem areas that might be within your project limits. If this is a concrete rehabilitation project, they can give you information on where the failures have occurred, how often they have occurred, and what they've done to repair them. This is all critical information for the pavement design so that we can make sure to address any issues. The District Materials Office should be involved to determine the availability of suitable materials in the construction area and any other special conditions that may exist. The geotechnical engineer should provide the estimated seasonal high groundwater table, which may impact your resilient modulus value. Normally, the stabilized subgrade resilient modulus for Florida is 16,000 psi. For Florida Select soils, a value of 12,000 psi is used for using pavement ME, as discussed on page 27 of the rigid pavement manual. Embankment utilization is covered under Standard Plans Index 120-001. The asphalt base option on this index is recommended. However, if the special select soil option is considered, this should be closely coordinated with District Materials Office for availability, cost effectiveness, constructability, and other special conditions. The District Planning Office will provide the current and future traffic data, including the projected easels. This office will also be aware of any planned developments that may be coming during the design life of the facility. The Planning Office will help explain whatever traffic data you find in the easel report and provide the context classification memo with the design speed that is appropriate to use for the facility. Close coordination with the design office to get guidance on the proposed typical section and the type of details that will be needed for widening locations or anything of that nature. The proposed typical section package should have the lane widths, design speeds, and any speed changes within the project and the overall project limits. Coordination with the drainage office is important to determine any special drainage considerations that need to be addressed. The pavement engineer needs to refer to FDOT Design Manual, FDM, Section 210.10.3 for vertical base clearance, to determine where the bottom of the pavement slab needs to be in relation to the base clearance water elevation, the BCWE. The bottom of roadway base, as referred in the FDM, for rigid pavement design purposes, is the bottom of the asphalt base, or the bottom of the concrete slab for special select soil option. Per FDM, the minimum clearance from the bottom of the roadway base course
to the base clearance requirements is 3 feet, except as noted in this slide. These exceptions are based on context class for some of the base clearance requirements. A 2-lane roadway in context classification C1, a C2, C2T, and C3 and all ramps may be reduced to a 2-foot clearance. A low point on ramps at crossroads may be reduced to a 1-foot clearance. In all other facilities in context classifications C4 through C6 may be reduced to a 1-foot clearance.
When you perform a field review, observe existing pavement conditions. Take photos of the deficiencies to keep good field records. Note any specific problem areas. Look at the distresses in the concrete pavement and identify potential base failures. You can use technology to capture high-level or resolution pictures to do analysis of the existing slabs, such as photogrammetry, LiDAR, or laser crack measurement systems. Concrete rehabilitation and widening projects verifying existing slab thickness by collecting additional existing data such as pavement coring and pavement evaluation and condition reports, or you can also obtain ground penetrating radar such as GPR to verify slab thickness. Any of these tasks will help verify the concrete slab thickness and compare with the existing as-built plans to develop accurate quantities. Resilient modulus data is provided by the geotechnical engineer. They will collect soil samples and coordinate with the state materials to provide a lab resilient modulus. Pavement condition report can be downloaded from the link provided in this slide. Each section of pavement is rated for cracking and ride on a scale of 0 to 10, with 0 being the worst and 10 the best. Any crack rating of 6.4 or less is considered deficient pavement and is marked by an asterisk. For speeds limits greater than 45 miles an hour, a ride rating of 6.4 or less is considered deficient. For speed limits less than or equal to 45 miles per hour, ride rating of 5.4 or less is considered deficient. 26 years of historic ratings are shown with ratings on these reports. The District Construction Office should be involved to determine if there are any specific information that needs to be included in the plans, such as special construction details or issues that need to be addressed with regards to constructability and construction time. Some of these items may include base types, stabilization, temporary traffic control plans, construction times, etc. For concrete rehabilitation projects, this requires usually closing 2 lanes at a time, mostly night work. Closing the 2 lanes allows enough space to cut the slab and set the equipment to lift the slab and bring the truck to pour a new slab. Coordinate any ramp closures and special detours if needed and lane closures to get work done. This concludes Module 2, Design Information Coordination. You're now ready to proceed to Module 3, Design for New Construction.